Okay, so this is from section 14D. It's question number 5. I didn't want you to have to do this one on your own, so I'm going to do it together with you. So it is very much like a IB test question. You'll notice at the top it says we can't use a calculator. All right, so first things first, it says show that the first derivative is negative 3 sine 2x. So let's just find the first derivative. Let's start over here with letter A. So f of x equals cosine of 2x, that's going to be chain rule, right? Plus cosine x, oh, that's going to be chain rule also. We've got 2 chain rules going on here. Okay, so that means my first derivative, to do the chain rule of this one, we need the derivative of cosine, which is negative sine, and then we're going to multiply that whole thing by the derivative of 2x, which is just 2. So if I simplify just that piece of it, I get negative 2 sine of 2x. Great. Now I'm going to do this one. I have the chain rule, so I got the 2 comes out in front. The derivative of cosine is negative sine. And that gets reduced to a 1, but I didn't, oh, I did that backwards. I was going to put it in, but I'm going to put it in the same order you're used to. Let's try that second part a little bit different. All right, again, the 2 comes down in front of the cosine of x. The exponent's now 1, and the derivative of cosine is negative sine. Okay, so we are subtracting 2 cosine x sine x. So what you need to do right now is you need to go to your formula packet and go in under trig, under the trig identities, and find that trig identity, 2 cosine x sine x, because that can be changed to a double angle formula. Okay, so this actually becomes negative 2 sine of 2x minus 1 sine of 2x. So that's negative 2 of them, and negative 1 more is negative 3 sine of 2x. Now, how did I know to go look for a double angle? Okay, so when I was going through this, I was looking at this and I was just going to stop here, but that's not the form they wanted it in. They purposefully made this a show question to force you into using that identity. So I went back over here and I said, crap, I got to get it down to sine 2x. Saw the 2 in front of the x and went, oh, there's going to be something double angle coming up here. So I had my formula packet already open to the double angle identities before I even hit this negative 2 cosine x sine x. So I was already anticipating that coming up. Okay, that's how I knew it was coming. Anytime I see sine or cosine of 2 times an angle, I always have out my formula packet with the double angles. All right, so the function has one relative minimum point on the interval from 0 to pi. Find the coordinates of that. Okay, so that relative minimum is going to happen when my first derivative is equal to 0, correct? Yeah, so I'm going to have, so for part B, I'm going to say my 0 is equal to negative 3 sine of 2x. Divide both sides by negative 3. I've got 0 equals the sine of 2x. Well, let's not think about that 2x quite yet, and let's also not think about that 0 to pi. Let's go ahead and do a full circle. You'll understand why in a second. So when does your sine, or your y-coordinate, equal 0? Okay, that's when the y-coordinate equals 0 at 0 degrees, or 0 radians, at pi radians, okay, at pi radians, and then if we're going the full circle, it happens again at 2 pi, right? So the reason I said go ahead and do all of those, even though it said we're only staying in between 0 and pi, is the fact that that's not what x equals, that's what 2x equals. Okay, so now what I want to do is I want to go ahead and do these divisions and see what happens. So 0 divided by 2 gets me x equals 0. Pi divided by 2 gets me pi over 2. And 2 pi divided by 2 gets me pi. So I actually have 3 x values. And I'm going to put them on my sign diagram. So here's 0, here's pi over 2, and here's pi. Because what I'm looking for is I'm looking for a relative minimum. The reason it's not 0 and the reason it's not pi is because those aren't relative. Those are my endpoints. So they don't fall within the smooth part of the graph, so they're not relative. Let's just verify through a sign diagram that this actually is a minimum. So let's test a value between 0 and pi over 2, like say pi over 4. So if I do 2 times pi over 4, that becomes pi over 2. And what is the sine of pi over 2? Well, pi over 2 is 90 degrees, and the sine of that is 1, which I'm going to multiply by -3, which makes it negative. Okay, and let's test a number between pi over 2 and pi. Let's say 3 pi over 2. So 3 pi over 2 times 2 is 3 pi, which is the same as pi when we're talking about rotation. So the sine of pi, oh, nope, I'm doing something wrong. Pi over 2, that's 1. Oh, 3 pi over 2 is beyond it. That's where the problem is. I'm at 3 pi over 4. So sorry. 3 pi over 4 times 2 is pi over 2. So pi over 2, the sine of pi over 2 is 1. And 1 times that is negative. What did I just do wrong again? I did 3 pi over 4, right? -3, I can't do this in my head, of 3 pi over 4, which would be 6 pi over 4, which would be 3 pi over 2. So the sine of 3 pi, there we go. The sine of 3 pi over 2, 1, 2, it's -270. So that's -1. And so that's a positive number. Wow. Glad I worked that out. All right. So in fact, we're going from a negative to a positive. So that is a minimum there. So we've got a minimum at pi over 2. And put that pi over 2 back in my original function. Yay. To get the y value. Yeah. Well, hello, Hudson. Would you like to say hi to everybody? Yes? Okay. Now you got to get down. I got to do some math work here. All right. So sorry, guys. Okay. So let's put pi over 2. Pi over 2. Sine of 2 times pi over 2. So the cosine of pi is -1. The cosine of pi over 2. The cosine of pi over 2 is 0, and 0 squared is 0, so -1 plus 0 is -1. So there's my minimum point. All right. Part C says find the second derivative. So let's go back and look at this first derivative here. Okay, so the second derivative, I've got to do the chain rule again. So the chain rule says it will be -3. What's the derivative of sine is cosine of 2x times the derivative of 2x, which is 2. So that gets me -6 cosine of 2x. Yes. And now I need to find the coordinates of the inflection points. We haven't done that one in a while. That's where your inflection points is where your second derivative equals 0. And we're going from 0 to pi again. So we might have to do this thing again where we go higher, okay? So 0 equals -6 cosine of 2x. Great. So divide by -6. 0 equals cosine of 2x. So when are your cosines equal to 0? Well, cosines are your x coordinates. So 2x happens, that happens, cosine happens to be 0 at pi over 2. And 3 pi over 2. And that's all it is in the one circle. So then I divide everything by 2, and I get that my x is equal to pi over 4 and 3 pi over 4. So oh, I should have changed colors, but I didn't. So this is my letter D starting here. So sorry. So my points of inflection become pi over 4. Let's go ahead and put this in. 2 times pi over 4 is pi over 2. And the cosine of pi over 2 is 0. Okay? And the cosine of pi over 4 is the square root of 2 over 2 squared. So the square root of 2 over 2 squared gets me 2 over 4, which is 1/2. So that's 1/2. My other one is 3 pi over 4. So 2 times 3 pi over 4 is 6 pi over 4. So 3 pi over 2, which is 0. What do we got here? The cosine of 3 pi over 4, 1, 2, 3. The cosine is the x, so it's negative square root of 2 over 2. But when I square it, I still get the 1/2. So there's my points of inflection. There was my second derivative. Here was part B for the minimum. And part A was a show. Oh boy. Alright, so I think that's actually going to be the last instructional video that I do for you guys for this school year. Okay, so hopefully I will see you on Tuesday if you have any questions.